Hello everyone, here is a question from ionic equilibrium. The following solutions were prepared by mixing different volumes of sodium hydroxide and hydrochloric acid of different concentrations. Among them, which one of them will give us pH value will be equal to 1? We know that pH is equal to negative logarithm of base 10 of the molar concentration of hydronium ions, or you can simply write it as H plus. In this case, the pH has to be equal to 1. If that is the case, what value of H plus will give us pH value equal to 1? Only if the molar concentration of H plus is equal to 10 to the power minus 1, then we can get pH equal to exactly equal to 1, because we can bring this minus 1 here, we have another minus here, and therefore become positive, and log 10 base 10 is simply 1, and we will get pH equal to 1. So what we are going to do is, if the molar concentration of H plus is not 10 to the power minus 1, then let us not calculate the pH, so that we can reduce the calculation a little bit. So let us check all the options one by one. We know that number of moles is equal to molarity times volume in liter. Here everything is given in milliliter, and therefore the number of moles we calculate is actually millimoles. Therefore millimoles equal to molarity times volume in milliliter. Therefore let us first calculate the HCl in millimoles. This will be equal to 1 by 10 mole per liter times 60 milliliter. This means 6 millimoles, and then number of moles of NaOH millimoles is equal to 1 by 10 mole per liter times 40 milliliter, and this will be 4 millimoles. Now we know that NaOH is a strong base and HCl is a strong acid. This means that 4 millimoles of NaOH will neutralize 4 millimoles of HCl. Therefore, what would remain in terms of millimoles for HCl? The remaining would be 6 minus 4, therefore 2 millimoles. Now if we want to talk in terms of concentration, then we have to divide by volume. The net volume here is 100 ml for the solution, therefore 2 millimoles divided by 100 milliliter. This is equal to 2 times 10 to the power minus 2 mole per liter. This will not give pH equal to 1. Therefore let us not do the calculation. Let's go for option B. Here let us simplify the calculation this way. The molar concentration is same. This means that 45 ml of NaOH will neutralize 45 ml of HCl. That means only what would remain? Only 10 milliliters of HCl. So that we will calculate. So HCl remaining for option B would be equal to 10 milliliter times 1 by 10 mole per liter. Therefore this will be simply 1 millimole. Therefore the concentration of H plus in this case is equal to 1 millimole divided by 100 milliliter. Therefore that is equal to 10 to the power minus 2 mole per liter. This also will not give us pH equal to 1. Let us go for option C. Here m by 5, here also m by 5. 25 ml of NaOH will neutralize 25 ml of HCl. What would remain? 50 ml. Therefore for option C, number of moles of HCl millimoles remaining is equal to 50 milliliter times 1 by 5 mole per liter. Therefore this will be 10 millimoles. That means the H plus concentration here is 10 millimoles divided by 100 milliliter. Therefore here we will have 10 to the power minus 1 mole per liter. This will give pH equal to 1. And therefore option C is correct, and that was written in 3. So option 3 is correct.